AI supercomputers, the trillion-dollar race to build an AI god. What if we could solve climate change, cure every disease, and maybe even unlock the secrets of the universe? It sounds like something out of a movie, right? But right now, nations and corporations are pouring over $1 trillion into a shadow race to build a machine that could do just that. Some are calling it an AI god. The big questions are, who's going to get there first, and what will it mean for the rest of us? The problem, hitting humanity's wall. Let's face it. For all our progress, humanity is staring down the barrel of some seriously complex problems. We're talking about irreversible climate change, diseases like Alzheimer's and cancer that our best scientists still can't crack, and a planet-wide scramble for energy and resources. Our usual way of solving things? It's just too slow. Even with our most powerful computers, it can take years, sometimes decades, to model a new drug or a complex climate scenario. We've hit a wall, a computational wall. Our problems are growing exponentially, but our solutions are stuck in the slow lane. This isn't just about needing faster spreadsheets. It's a fundamental bottleneck. And to break through, we need a whole new kind of intelligence, a tool that can see connections far beyond what any human can. This is what has ignited the most expensive, and maybe the most important arms race in history. A race not for land, but for pure computational power. The stakes. A new geopolitical chessboard. This isn't some quiet competition in a university lab anymore. This is a full-blown global conflict, fought in boardrooms and government halls, with well over $1 trillion on the table. The two titans in the ring? The United States and China. Both see AI supremacy as the key to dominating the 21st century. While U.S. private investment in AI far outstrips China's overall R&M, spending is growing at a significantly faster rate, with the performance gap between the top AI models from each country shrinking rapidly. Some experts speculate the U.S. lead in developing the most advanced AI models could be as narrow as 3 to 6 months, though the true gap is hard to nail down. But it's not just a two-horse race. The UK, for example, recently announced the Tech Prosperity Deal with the US, a partnership backed by tens of billions in private investment from American tech giants to build up Britain's own sovereign AI capabilities and ensure it's an AI maker, not an AI taker. The new currency in this world isn't gold or oil. It's computational power, measured in flops, floating point operations per second. And the numbers are just staggering. We're in the era of exascale computing now, with machines capable of a quintillion, that's a billion calculations per second. That's like every single person on Earth doing a math problem every second for over 4 years, all in the time it takes to blink. The financial commitments are just as mind-boggling. Microsoft plans to spend around $80 billion in 2025 on AI-enabled data centers. Amazon isn't far behind, with some projections for its 2025 AI infrastructure spending exceeding $100 billion. And then there's the really ambitious stuff. You might have heard of a project called Stargate. It's not the $100 billion supercomputer people were talking about last year. The latest reports describe the Stargate initiative as a massive $500 billion private sector plan involving OpenAI, SoftBank, and Oracle. It's a proposed AI supercomputer that could require up to 5 gigawatts of power, enough for a small city, and might even need its own dedicated nuclear plant just to run. The solution: building the Exascale machines. So, how do you even build one of these monsters? It all comes down to a special little chip, the GPU or graphics processing unit. Yeah, the same tech that makes your video games look so good. It turns out its design is perfect for the kind of parallel number crunching that AI needs. And one company, NVIDIA, has the market in a chokehold, with its chips powering over 80% of the AI data center market. That dominance has made NVIDIA the undisputed kingmaker in this race. But nobody likes a monopoly. That's why giants like Google, with their own TPUs, and Amazon, with its Trainium chips, are racing to design their own custom silicon. These individual chips are then packed together by the tens of thousands into what people are now calling AI factories. Take the world's first official Exascale supercomputer, Frontier, at Oak Ridge National Laboratory in the US. It was built for around $600 million and contains thousands of CPUs and tens of thousands of GPUs. Its successor, Aurora, also in the US, cost around $500 million and is designed to push performance even further. These aren't just computers, they're strategic national assets. And the ambition is only growing. As part of UK-US collaborations, projects are underway to deploy tens of thousands of NVIDIA's next-generation GPUs. We are literally watching our planet's infrastructure get rewired, away from just roads and bridges, and towards a global network of hyper-intelligent machines. Mid-roll CTA. Okay, quick break. If you're getting as fascinated by this as we are, hit that subscribe button. We're tracking this story non-stop, and you're not going to want to miss what comes next. The breakthroughs. An AI-powered future. That $1 trillion-plus price tag is a lot to swallow, but the potential payoff is, well, almost infinite. These AI supercomputers aren't just for making chatbots sound more human. They're about to change scientific discovery forever. Take healthcare. By simulating how molecules interact on a massive scale, these machines can accelerate the search for new medicines. What used to take years of painful lab work can now be done in a fraction of the time. This is opening the door to truly personalized medicine, where treatments for diseases like cancer are tailored to your unique genetic code. Right now, the world's top supercomputers are being used to study everything from the inside of a nuclear reactor to how drug-resistant bacteria behave. And it goes way beyond medicine. In Europe, the Across project is using AI to help design more efficient aircraft and generate scarily accurate weather predictions. Other models are improving carbon capture technology, which is critical in the fight against climate change. In materials science, AI can dream up brand new materials with incredible properties before they even exist, paving the way for better batteries, cleaner energy, and who knows what else. It's not just an improvement. It's an acceleration of science itself. The double-edged sword, the god and the golem, the promise is incredible. But creating machines this powerful comes with some serious risks. The same AI that can design a life-saving drug could also be used to design a terrifying bioweapon. An AI that can optimize a power grid could also be used to crash it. It's the classic double-edged sword, the power to solve our biggest problems, and the power to create brand new ones we can't even imagine. One of the most immediate worries? Jobs. As AI gets cheaper and smarter, entire industries could be wiped out. Then there's the insane energy demand. We mentioned these AI factories need a lot of power. To give you an idea of the scale, Meta is planning for its global data center infrastructure to consume multiple gigawatts of power. The question is becoming, can our power grids even handle this? And then there's the really tricky part, who's in charge? Who decides what problems these AI gods work on? Who's responsible when they mess up? An AI trained on biased data could make our society's inequalities even worse in everything from who gets a loan to who gets a job. Without a lot of very careful, globally coordinated planning, we risk building a future that's incredibly efficient, but also profoundly unfair. The race to build an AI god is also a race to find the wisdom to control it. We are at one of those moments in history you read about in books. The trillion-dollar race for AI supremacy isn't just a tech story. It's the story of what's next for humanity. Nations and corporations are betting their futures on these massive machines, redrawing the geopolitical map where the ultimate prize is shaping reality itself. From Frontier in the United States to the new AI factories popping up across the UK, this is our generation's Apollo program, but with stakes that are so much higher. Yes, these systems could unlock the answers to our most existential threats. But they also force us to face some really hard questions about control, ethics, and our own future. This isn't science fiction anymore. It is happening right now. The AI god is being built, one calculation at a time. The question is no longer if these machines will change our world, but how. And as this unimaginable power comes online, who will be holding the leash? So what do you think? What's the biggest promise here, and what's the biggest risk? Drop your thoughts in the comments. And if you want to stay ahead of the curve on all this, make sure you're subscribed with notifications on. Thanks for watching.